So page 5 starts off, it says, how did Marty do on his test? How did Marty do on his Chapter 1 AP Stats test relative to his peers? What does that part mean? That relative to his peers. What'd you say? Compared to his peers. So compared to the other people in his class, like he might have only gotten a 65 on his test, but if everybody else did worse, that 65 is not a horrible grade. Hopefully the teacher would curve it then. But the idea is that compared to the other people in the class, how did he do? Here's a sample of the Chapter 1 AP Stats test scores. The mean score is 80, standard deviation is 10. We could actually calculate that. We don't need to. They did it for us already. Nice thing, they've got all of these test scores in order for us from lowest up to highest. So lowest was a 60, highest was a 99. Yesterday, we talked about percentiles. Let's calculate the percentile for Biff as an example, and then I want you guys to figure out Marty's on the next one on question 3. So Biff scored a 65. What is Biff's percentile? How do we calculate a percentile? Yes, a percentile would be how much of the data is at that point or lower. So Biff scored a 65. Did he score this 65 or this 65? Or does it matter? Doesn't matter. We're going to include both of them because there were 2 people that got a 65 and then everything below that. So this is what we want for Biff's percentile. So how many people scored a 65 or lower? 3 out of? Three out of 20. That's okay. There's 20 numbers there, yeah. 3 out of 20 would put him at what percentile? 15th percentile. Was Biff above or below the mean score for this class? Below. How much below? How many points below was he? He's 15 points below. How'd you come up with that? 80 minus 65. 80 was the mean. We were told the mean score right up here. And then we've also been told the standard deviation right here. All right, so Biff is 15 points below the mean. How many standard deviations would that be? What'd you say? 1.5. What'd you do? 15 divided by 10. Absolutely. 1.5 standard deviations below the mean. So when I want to know how many standard deviations away they are, it's like I'm coming up with a new ruler that's as big as that standard deviation. I'm seeing how many of those would fit in between the mean and his point. So 1.5 standard deviations below the mean. I want you guys to do this exact same thing on numbers 3 and 4 for Marty. I want you to find Marty's percentile. I want you to determine whether Marty is above or below the mean, both by how many points and by how many standard deviations. Let's take about, I don't know, somewhere between 1 and 2 minutes. So what is Marty's percentile? 95th percentile. How many points above or below the mean was he? 17 points above the mean. I'm assuming it's above the mean, right? You got a 97. How many standard deviations away from the mean was he? 1.7. Yes. All right. So what I've been leading up to is this idea of a z-score. A z-score is defined as the number of standard deviations above or below the mean. So this number right here, when you said it was 1.7 standard deviations above the mean, that's a z-score. We're going to use z-scores from now until May. They come up a lot. They have a lot of applications here. How do you think we would indicate, if I'm just giving a score, just a number, whether it's above or below the mean? How would you know just by looking at the number whether it's an above the mean or a below the mean number? If it's positive or negative. So would Marty have a positive or negative z-score? He would have a positive z-score. So his z-score would be 1.7. So positive meaning above the mean. So what would Biff's z-score be? I'm sorry, I didn't hear. Negative 1.5. So negative meaning below the mean. So we're going to write down our formula to find a z-score. Walk me through what we did on Marty. Okay, let me switch over to where Marty is again. Walk me through what we did to Marty to arrive at a z-score of 1.7. What did we do first? Yep. How far away is he from the mean? Did we put his number first or second? We put his number first, and we put the mean second. With Biff, we did it the other way around, which meant we ended up with a positive number, and we just said below what the mean was. But we're always going to keep it whatever the value is first, and then minus the mean. So if it's bigger than the mean, it'll come out to be a positive number. But if it's smaller than the mean, it's going to come out to be a negative number. That's how we force it to be either positive or negative, so I know whether it's above or below. And then after we subtracted, what did you do to get that z-score? How did we get the 1.7 here? Divide it by 10. What was 10 again? The standard deviation. Yes. So for our z-score, it is the value minus the mean divided by the standard deviation. Value minus the mean divided by the standard deviation. We call a z-score a standardized score. Basically what we're doing is any kind of distribution, any kind of data we're looking at, when we calculate these z-scores using the mean and the standard deviation, it allows me to compare apples to oranges. I'm making them both into apples so that I'm comparing apples to apples. So Marty's z-score was 1.7. Maybe we look at how he did in another class, and his z-score comes out to be 0.8. The other class might have had a test out of 50 points, and in his stats class it was out of 100 points. So if you just compare how many points above or below the mean he is, that's not going to tell you much. Because if it's out of 100 points in one class and out of 50 points in the other class, He could get the same percent, the same grade, but be very different in the number of points he missed. Does that make sense? So it's going to allow us to talk about where a piece of data, oftentimes a person, falls in relationship to the other people that are there, and then I can look at another group and I can compare location of any other individuals there as well. So it's a standardized score. Goldie got a 93 on the Unit 1 test. I want you to find the z-score. We're going to talk about the interpreting in just a minute. Find the z-score for Goldie. So value minus mean divided by standard deviation. What is her z-score? 1.3. All right, so now let's talk about interpreting this. Anytime we're interpreting, we are recontextualizing these things. We're putting them back in context. So I would start my interpretation with kind of restating most of this. I would say Goldie's Unit 1 test score was how far away from the mean? How many standard deviations away from the mean? 1.3, above or below? Above the mean. That would be my interpretation in context here. Goldie's Unit 1 test score is 1.3 standard deviations above the mean. Absolutely.
How with this we got a negative and for the rest we got a positive. Is that only when we put their number behind when we're multiplying? I meant subtracting.
So with Biff, the first time we talked about it, we got a positive number because we did 80 minus his score. But to calculate the z-score, we always do score minus mean.
Okay.
And so that's how we force it to be either a positive or negative, telling me whether I'm above or below, just based on the sign of the number.
Okay, thank you.
You're welcome. All right. We're going to try something a little bit different. I'm going to explain the task. You can find some people to work with. I'm not going to give a super long time. But I want to see if we can create a scenario where this is true. Lorraine scored 1.4 standard deviations above the mean on her first biology test, and 1.9 standard deviations above the mean on her first psychology test. Create a scenario where her biology test score is higher than her psychology test score. So she's only 1.4 standard deviations above the mean on her biology test. She's 1.9 on the psychology test. But relative to her peers, she's only 1.4 standard deviations above the mean versus 1.9. I want to go through and look at some of the things that we've done already to hopefully help you guys a little bit. I'm not going to give very long, but I want you to kind of work on this on your own, play around with it a little bit, and then we'll come back together. It's fine if you can't come up with a final answer, but I want you to get your brains working on this idea. So one of the things that I really liked about our example with Marty and Biff is that standard deviation made it really easy to divide. You guys are going to come up with, let's pretend the standard deviation is blah. You get to come up with that number. You get to come up with, what did she get on her test? You get to come up with what was the mean of the class. You're going to generate all of this stuff. We don't have the data from the classes. you're going to make it up. But I want you to make it up in such a way that on the biology test, the standard deviation is 1.4, but on the psychology test, the standard deviation is 1.9. You can decide on all of these numbers. I want to see if you guys can do this. When you do her test score minus the mean that you make up, divided by the standard deviation that you make up, for biology, you get 1.4 as the answer. For psychology, you get 1.9 as the answer. I'm going to give us let's take about 3 minutes because I don't want to frustrate you too much, but I do want you to kind of work on it a little bit. You are welcome to work with some other people if you have some ideas. I would try picking out a standard deviation that's an easy to divide by number so that you can try to force this to happen. Thank you so much. You get to decide whatever you want this to be.
Yes, so we have to like work That's crazy. Okay, so here's what we
But I am saying that where she got on the biology test, it's a higher than on the psychology.
Yeah, okay, but am I gonna miss anything like major?
I don't think so. I mean, if you go quickly. The longer you're gone, the more you'll miss. So. You're welcome. All right. Let's talk a little bit about this.
Sorry,
You're fine. Let's talk a little bit about this. If I want to force the z-score to be 1.4, that means when I do this division part, it has to come out. It has to equal 1.4, right? What's on the denominator when we find a z-score? Standard deviation. How do we get the numerator? Value minus mean, or score minus mean, right? So if I want to make this easy on myself, I'm going to pick my standard deviation first. What strikes you as some easy to divide by numbers? 10 certainly seems like a very easy to divide by number. If I'm dividing by 10, what would my numerator have to be if I want the answer to come out to be 1.4? It would have to be 14. All right, so let's go ahead and stick 10 in the biology standard deviation. We're going to put the biology test score here and the biology mean here. Remember, we want her biology test to be higher than her psychology test. How do you think she did on her biology test? Give me a number. What do you think she got? You put a 65 for her test score? She has to score lower on the psychology test. You said 65. Let's go with that. All right, if I put a 65 here, what would the mean have to be in order to force this to come out to be 1.5? Or sorry, 1.4, not 1.5, sorry. Oh, you put a 79 for that? For the biology mean? All right, if we do 79 here, remember it's value minus mean divided by standard deviation for our z-score. So let's plug these numbers in and see if it comes out. Oh, you did mean minus value. We got to do value minus mean. Should we fix some of our numbers first? All right, so give me, yeah, that's going to come out to be a negative. Give me some numbers to put in for her biology test score. 90, sounds good. 90. What would the mean have to be if the z-score comes out to be 1.4? 70, 71, 76. Let's try 71 first and see what happens, see if it's 76. Value, 90, minus mean, 71. What is 90 minus 71? 19 over 10. When I divide that, I get 1.9. But remember, biology standard deviation should come out to be 1.4. 76. All right, let's try that. Okay, so 90 minus 76 gives me what? 14 over my standard deviation of 10. We get a z-score of 1.4. Cool. Psychology now. Do you guys want to keep the standard deviation at 10 or change it? Keep it at 10? Sounds good. Now remember, she did better on the psychology test than she did, oh wait, sorry, biology test is higher than psychology test. My bad, I'm reading it backwards. So give me something that her psychology test score could be. A 60? Oh, 64? All right, let's do 64. If her psychology test score was 64, what would the mean on the psychology test have to be so that the z-score comes out to be a 1.9? $43, 40, 45. Let's try 43. It's just the first number I heard. 43 is the first one that I heard. Okay, so test score 64 minus mean of 43. Is that coming out to what you want it to be? Okay, so help me change this back number. 45. When we do 64 minus 45, what do we get? 19. Over our standard deviation of 10, comes out to be a 1.9. Cool. She got a lower score, substantially lower score, but she's more standard deviations above the mean. So should she be happy with her psychology grade? Compared to the other people in her psychology class, should she be happy with her psychology grade? Compared to the other people that took the psychology test, she is above the mean. Remind me what we're working on, dear.
Oh, I just came here. Did we start notes yesterday? Like the new package?
Yes. Yes, you need a new packet.
Yeah.
Very back, you'll need the orange packet and the paper right below it. All right. So yeah, I would say compared to the other people, like as they get their test back and they're looking, the bottom one, that same color. Yeah. Sorry, I know that's a little confusing. And they start looking at each other. What'd you get? What'd you get? What'd you get? She passed the test. Most people didn't pass the test. The class average was 45. Hopefully that teacher curves the test.
Thank you.
You're welcome. So I would say that compared to her peers, she did better on which test? I mean, as a parent, I'd be more happy with the biology grade than the psychology grade. So as far as like grade-wise, but yeah, compared to the other people that took the biology test, compared to the other people that took the psychology test. So just relative to the other people, I'm not thinking grades anymore. Relative to the other people in the class, which test did she do better on? Psychology. She got a lower score, but compared to the other people, she did better. That's when you go home and you tell your parent, look, I know I got a 64 on the test, but everybody else failed this test. So I am thrilled with my 64 because I passed. It depends on the class. Personally, if the average for the test is a 45, I'm hoping that the teacher helps fix that a little bit. All right, let's go ahead and flip this over on the back side. All right, thank you. And your phone needs to go in pick a pocket. It doesn't matter.
Wait, this is a different class.
Oh, I'm sorry.
So do you need yours?
No. There you go. You're welcome. All right. So two different things that we're looking at here. Standardizing a distribution. Whenever you see standardizing or standardized score or standard score, we're talking about a z-score. Those get used as synonyms. Somebody could say, what's the z-score for this, or what's the standardized score? Same thing. Value minus mean divided by standard deviation. Always value minus mean, even if it comes out to be a negative, because that's how I'll know that it's below the mean, not above the mean. Interpreting this in context, context is whatever your z-score is, standard deviations above or below the mean. That's the meaning of that score. And then z-scores show our position relative to other values in that distribution. So again, I want you to think of like the psychology and the biology test. Relative to the other people in that class, relative to the other people in that distribution, she did pretty well. I want you guys to look at the check your understanding. Try those 4 problems. And I'll check back in with you in about 5-ish minutes. Number 1 is review from yesterday.
Tell me when I put this in parentheses, like x2, so 4, and x1, this is negative. X1 is negative 8, that turns into positive.
On this one, you're not going to make the standard deviation. You've got your summary statistics right here. There's your standard deviation. And there's your mean. Okay, thank you. You're welcome.
Is this set up right for the zero?
Mm-hmm.
Oh, that's a crazy number. Okay.
I wouldn't write down all the decimal places. I'd write down 2 or 3. 3, yeah, I'd probably go 3. Yes, ma'am. So, what was the value for Utah? Because remember, this is number of public colleges. How many public colleges does Utah have? Not how many are above or below.
Oh.
How many public colleges does Utah have?
Oh, let's see. 17.
So that's what you're going to put in for your value.
Right.
Hundreds is 2 places.
2, sorry. Thank you.
You're welcome.
about a minute left, and then we're going to go through it. Piece of lead.
Oh, okay.
And I'm back. Yep. Pop your phone into any pocket. Thank you. And then find one of the open seats in this row here. All right. What do we need to know to calculate the percentile? How many are at or below Utah's number of colleges? So I'm glad they pointed out exactly where Utah is. How many dots are at or below where Utah is? 13, 14, which one? It's 14, because remember, at or below. So we have to include Utah and everything below it. So 14 out of 50, which would put it at what percentile? 28th percentile. So now let's we calculated that. Let's interpret that. What does that mean that it has a 28th percentile, or that it's at the 28th percentile? %28 of the states have, I didn't hear the rest of your sentence, I'm sorry, have 17 public colleges, full stop, 17 or less. 28% of states have 17 or less public colleges. For number 2, to calculate the z-score for Utah, do I care how many dots are at or below Utah? What are the numbers that I need to calculate the z-score? I need the mean and the standard deviation. We've got those right here side by side for us. And there's one other number I need. What do I need? The 17. That value. Remember, we're looking at number of public colleges. So whatever Utah's number of public colleges is, that's our value. What'd you guys get for the z-score? Negative 0.677. Negative 0.677. Because remember, it's always value minus mean. The mean is bigger, so we ended up with a negative number. Now, how would you interpret that? We start with context. What's our context here? So Utah's number of public colleges. Is 0.677 standard deviations below the mean. The number of public colleges in Utah is 0.677 standard deviations below the mean. Michigan has a standardized score of 0.267. What does that mean? You got my answer for me. What does standardized score mean? Z-score. Standardized score means the Z-score. So we know the Z-score. Do we know the standard deviation and the mean? So we've got one unknown thing here. We don't know how many public colleges they have. We don't know their value. So how do I do this? call it an x. X minus 39.24 over 32.844 equals 0.267. And then I multiplied both sides by my denominator to get that 8.769. That's just timesing by my denominator. And then you add the mean, the 39.24, to both sides so that we get x all by itself. And you come up with what? Yeah, I got 48.009. We can't have 0.009 of a college. So how many colleges do they have? 48. We're going to round that just to 48. Michigan has 48 public colleges. Yes?
Yeah, how do you get that?
Okay, so you guys are good with how I set up my fraction, right? Okay. What operation is a fraction bar? Dividing. What operation undoes dividing? Multiplication. Yep. So what we're going to do is we're going to undo this division by multiplying by that 32.844. That'll cancel my denominator out. Notice this was my numerator. And if you do it to one side, have to do it to the other side. 32.844. That's how I got that 8.769. Last one, number 4. For the distribution of number of public colleges, Michigan has a z-score of 0.267. For the distribution of number of private colleges, Michigan has a z-score of 0.228. Which z-score is higher, public or private? Public. Barely higher, right? A little bit higher. Does that mean that Michigan has more public colleges than private colleges? Not necessarily. What does it mean then?
It means that
Joanne. Standard deviation could be less. The mean could be, you said, greater? Yes. It means, yeah, you're not wrong. I liked your answer. Compared to the other states, they have more private colleges. But it does not mean that they have more private colleges than public colleges. Remember, this number right here is telling us compared to the other states, where do they place in number of public colleges? This number down here tells me compared to the other states, where do they fall? It's not giving me an exact number here. And without the mean and the standard deviation, I can't find the number. I can't figure out how many private colleges they actually have. Higher z-score simply indicates the value is more standard deviations above the mean than the value for the private colleges. And then to echo kind of what Joanne had said, without knowing x bar, what does x bar mean again? Mean. Whenever you see x with that little line over it, that's the mean. Without knowing the mean, without knowing x bar and the standard deviation for the private colleges, we can't determine the number. Only the position relative to the other states. And that finishes us up for today. I realized yesterday, after the fact, of course, like long after everybody was gone home on the buses, that I forgot to tell you when the next test date was, and you've got a spot on the front of your notes that you can write down the next test day. As of right now, the test is set for Wednesday the 28th, which is 2 weeks from yesterday. So we spent 2 weeks on the first chapter. The plan is we're going to spend 2 weeks on this chapter. Looking at your homework, because some people like to work ahead, some people like to do it before the night before it's due. There's only one problem on the homework that we haven't talked about how to do yet, and it's the very last problem. You've got 5 problems on the homework. Number 5 is the one that we will discuss how to do on Monday. But 1 through 4 is all stuff that we have now covered.